Well, for our next mixture problem, we have how much alcohol must be added to 24 gallons of 14% solution of alcohol in order to produce a 20% solution. Well, I don't know how much alcohol, so I'll just put P. And what part of pure alcohol is pure alcohol? Well, 100% or 1, and 1 times P is P. Now, how much of the solution is there? Well, there's 24 gallons, and what part of that is alcohol? Well, 14% or 0.14, and the product of these two is 3.36 gallons of pure alcohol. What's the total amount? Why, it's P plus 24, and what part of the final amount is supposed to be pure alcohol? Well, 20% or 0.20. And how much pure alcohol will we have in the end? Well, we'll have P plus 3.36 gallons. Now, we have a couple of equations awaiting us. One is this. We need 20% of the total solution will be pure alcohol, so that'll be 0.2 times P plus 24. And how much alcohol is there? Well, there's going to be P plus 3.36. Now let's get rid of these decimals, and we'll do that by multiplying both sides by 100. So 100p plus, multiplying 3.36 by 100, we get 336, which equals, multiplying 0.2 by 100, we get 20, and times P plus 24. We only multiply the 100 times one factor the other, not both. So now we've got 100p equals, plus 336 equals 20p plus 480. Now we'll subtract 20p from both sides and get 80p, and we'll subtract 36 from both sides and we'll get 144. Now dividing both sides by 80, we'll get 144 over 80, which reduces to 9/5. And in decimal form, we have P equal to 1.8. So we need to add 1.8 gallons of pure alcohol to raise the percentage of alcohol in the solution up to 20%. And we're done. Well, here's our final mixture problem, and we have a solution. A is 50% acid, so I've got 0.5, and I'll just, how much is there of it? Well, there's cc's of it, so we have 0.5 A. And we have another solution called B, and how much is there of it? Well, we don't know, we'll just call it B, and it's an 80% solution, so 0.8. And the product of these two is 0.8 B. And the how much of each should be used to make 100 cc's. So our total volume is going to be 100 cc's when we're done. And the solution, the percentage in this of acid in this solution should be 68 or 0.68. And so now the final volume is going to be 0.68 times 100. So moving that decimal over twice, multiplying by 100, we will get 68. So we're going to get two equations, two unknowns out of them here. The first equation is A plus B equals 100. The next equation is, and that's the total amount of liquid. The total amount of the acid is going to be 0.5A plus 0.8B, which equals 68 cc's. Hey, we have two equations, two unknowns. Let's do two things here. Let's get rid of these decimals. So I'll multiply the bottom row by, and we'll have A plus B equals 100. We'll multiply this bottom row by 10, and that way we will get rid of the decimals. So we have 5A plus 8B equals 680. And notice I multiplied both sides by 10 to move the decimal over one place. So now I'll multiply this top equation by negative 5. And if I do that, I get negative 5A, negative 5B equals negative 500. And for the bottom equation, it will remain as is, plus 8B equals 680. And now when we add these up, the A's add out, and we get 3B equals, and the difference in these two is 180. Dividing through by 3, we get B equals 60. So if B equals 60 and the sum of the two has to be 100, then A must equal 40. And so we need 40 cc's of A solution and 60 cc's of B. And we're done.